Now let's begin with the application of crystal field theory to octahedral complexes. In octahedral complexes, it is assumed that metal ion is at the center of regular octahedron, and ligands are at the six corners of the octahedron. This is metal, and these red dots, these are ligands, and they are present at the six corners of the octahedron. Now the Eg orbitals, Eg means which one? Dx square minus y square and dz square. These are directed along the axis. While the T2g orbitals like dxy, dyz and dzx, these point in between the axes. You need to remember this point that Eg orbitals, they are present along the axis, while T2g orbitals, these are present in between the axes. Now, when six ligands, they approach, these six ligands, they approach along the axis like x, this is minus x, y, this is y, so this is minus y, and this is z, so it will be the minus z. Now when six ligands, they approach towards the metal ion, they always approach along the axis, and hence they increases the repulsion and the energy of Eg orbitals, because these orbitals are present along the axis, so they increases the energy of the Eg orbital much more than the T2g orbitals like dxy, dyz and dxz orbitals, which point in between the axes. Thus, under the influence of octahedral ligand field, the d orbital of the metal split into two groups of different energy. Now listen here, again I am repeating, according to CFT, in octahedral complexes, it is assumed that metal ion is present in the center, and ligands, six ligands, they approaches along the axis. Okay. Now, d orbitals, they are of two types. Those are Eg and T2g. Eg are present along the axis, while T2g, they are present in between the axis. And hence, when ligand, they approach along the axis like x, y and z, these ligand electron and Eg electrons, they start repelling each other, and that's why the energy of Eg orbitals electrons increases as compared to the T2g, because T2g orbitals, these are not present along the axis, but these are present in between the axis. So they experience quite less repulsion. So Eg, their energy is increased, while T2g, their energy is comparatively decreased. Here in this diagram you can see here degeneracy and splitting of d orbital is very well explained in this diagram. Here in a free metal ion, the 5d orbitals, they have equal energy, or these orbitals are degenerate. That means these are energetically equal. And electrons which occupy such orbital, they follow the Hund's rule of maximum multiplicity. Here, when the d orbitals, they are spherically symmetrical, or when they are present in the field of spherically symmetrical field, then their energy is slightly increased, but all the d orbitals, they are present in the same energy level. But when ligands, they approaches towards the metal ion in octahedral field, here what happened, the ligand exerts an electrostatic field which causes the repulsion, and this repulsion raises the energy of the d orbital of central metal ion. In the way, the 5d orbitals would remain degenerate at higher energy level. But what happened? We know that d orbitals, they are of two types. They are not same. They are of two types. Those are T2g and EG. T2g orbitals, they are present in between the axis, while EG orbitals, they are present along the axis. So as the ligand approaches along the axis, there is a repulsion between ligand orbital and EG orbital, and definitely the energy of EG orbital is increased than the average energy, while the energy of T2g orbital is decreased than the average energy level. So here in octahedral field, we get two different energy levels of, one is T2g, which are in lower energy level, while EG, they are having upper energy level or higher energy level. Here, the splitting of d orbital, it is very well explained in this diagram also. These are the metal d orbitals which are present in same energy level or which are degenerate. But when metals are surrounded by ligands in spherically symmetrical field, then their average energy is slightly increased, but still they all are having the same energy or degenerate energy. But when ligand approach in octahedral field, there is a splitting of d orbitals. Two d orbitals, that is dx square minus y square and dz square, their energy is increased, while the energy of T2g orbitals, that is dx square y, dyz and dxz, their energy is decreased. So the increase and decrease in energy, it is shown here. This energy, average energy, is also called as barycenter. This is called as barycenter. While these EG orbitals, their energy is increased, so it is shown by plus sign, and these T2g, their energy is decreased, it is shown by minus sign. Now, how much energy is decreased for T2g? It is shown by 2 by 5. 2 by 5, what it indicates? That out of 5 orbitals, in comparison with 2 orbitals, these 3 orbitals, their energy is decreased, so it is shown by 2 by 5. While EG orbital, their energy, there are 2 EG orbitals. Out of 5, 2 EG orbital, their energy is increased as compared to these 3 orbitals. So these are shown by their energy is increased by 3 by 5. And this is the total energy, which is denoted by delta O. Here delta O is known as splitting energy of octahedral complexes. This delta O, the total energy is considered as a 10 dq, where we will see the meaning of 10 dq. And this 10 dq, when it is divided, the decrease in energy, it is by minus 4 dq, while increase in energy is by plus 6 dq. How these are calculated? 10 into 3 by 5. This is 3 by 5, so it comes equal to 6 dq. And here the decrease in energy is 10 into 2 by 5, which is minus, so it is equal to 4 dq. So the decrease in energy is by 4 dq. Now remaining part we will discuss in next.